So 3-5-note system 3-variable equation substitution method is what we're doing, okay? So for the substitution method, here are our steps to solve. Remember, these steps are available for you on Canvas, so don't feel like you have to get them all down right now. So one, we want to make sure equations are written in standard form, meaning that our variables, our terms with variables are all together in alphabetical order, and our coefficient is by itself. And then we're going to number the equations. The purpose of numbering the equations is just for referencing and helping yourself stay organized. Step 2, we're going to choose the equation that would be the easiest to get a variable alone. So going for a variable with a coefficient of 1. So we can get that variable alone. That's a sign that you should be using substitution, or you could be using substitution as if a variable has a coefficient of 1. Step 3, we're going to substitute the expression into the other two equations and simplify it to standard form, okay? Simplifying to standard form again means that terms with variables are on one side and the coefficients on the other. Step 4, we're going to write the two new equations as a system and solve using either elimination or substitution for the two variables. And then step 5, we're going to substitute the two variables into the equation in step 2 and solve for the last variable. Okay. And then step 6 is to check your solution set by substituting values into all three equations. So steps to solve with substitution. Now, here is our first problem that we're going to do. So step 1 is to make sure that we're in standard form. All terms with a variable are on one side and in alphabetical order-ish. This one's not, but it's okay for substitution. It really doesn't have to be. And the constant is on the other side. So step 1, check. Oh, and then number for referencing. Okay. Step 2 is to decide on an equation to get a variable by itself. So looking at equations 1, 2, and 3, which one has a variable with a coefficient of 1?
2.
Equation 2 has a variable with a coefficient of 1. So we're going to use equation 2, which is x plus 5y equals 9. So to get x by itself, we're going to subtract 5y. So we're going to be working with x equals 9 minus 5y. Okay, so step 3 is to substitute that variable into the other two equations. So we're going to substitute it into equation 1, and that gives us 2 times 9 minus 5y plus 3y minus 2z equals -1. And we're going to distribute and combine like terms. So we have 18 minus 10y plus 3y minus 2z equals -1. 18's like terms on the other side, so we have to subtract it. -10y and 3y make -7y minus 2z equals -19. We got our first two variable. And then we're going to substitute into equation 3, because that's the other one we haven't used. So we have 4z minus 5. For x, we're putting in 9 minus 5y. And that gives me 4z equals, distribute, 4z equals 4. 4z minus 45 plus 25y equals 4. Combine like terms. Well, combine like terms means I'm going to move 45 to the other side. I'm going to write it as 25y plus 4z equals 49. So there's my second two variable. So that's step 3. Questions about step 3? Okay, step 4. We're going to solve the two variables either by elimination or substitution. We know we are not using substitution because there isn't a variable with a coefficient of 1, and also, that's the main reason, there isn't a variable with a coefficient of 1, or have common factors that will simplify. So we have negative 7y minus 2z equals negative 19, and we have 25y plus 4z equals 49. So if I'm solving by elimination, which variable am I going to work on eliminating?
Z.
Z. Good job, Devin. I'm going to eliminate z. So I'm eliminating z, which means that what would I need to do to transform negative 2 into the opposite of positive 4? Well, I would have to multiply everything by 2. So now I'm working with negative 14y minus 4z equals negative 38. And I have 25y plus 4z equals 49. When I combine, my z's are going to cancel, and I'm left with negative 14y plus 25 is going to give me 11y, which equals 11. So we know that y equals 1. And I'm going to take the value of y and I'm going to substitute it back into either one of these. So I'm going to substitute it into either this guy, or I'm going to substitute it into that guy.
Can't you substitute x equals 9 minus 5y to get x?
Yes, I'm going to do that in the end. I'm just going in order. And so, yes, I can go ahead and jump to that substitution. I was just waiting. I'm going to solve for z. So solving for z, I end up with, I'm going to use the smaller one, by the way. So negative 7 times 1 minus 2z equals negative 19. Negative 7 minus 2z equals negative 19. I'm going to add 7. Gives me negative 2z equals negative 12. Divide by negative 2. I'm going to squeeze that in there. And that gives me z equals 6. So I've completed step 4. Step 5 is to take the information that I got and plug what I need to back into step 2. So plugging back what I need to step 2, that would just be the y, right? All I need to do is substitute in y. So x equals 9 minus 5 times 1, which is x equals 9 minus 5. So x equals 4. So my solution is 4, 1, 6. Okay? And then step 6 is to check yourself. So checking myself is very simple. It doesn't have to be elaborate, doesn't have to be drawn out. You can just simply use the equation you wrote down first and write the numbers on top. So 2 times 4 is 8. 3 times 1 is 3. 2 times 6 is 12. 8 plus 3 is 11. 11 minus 12 is negative 1. 4. 5 times 1 is 5. 4 plus 5 is 9. 4 times 6 is 24. 5 times 4 is 20. 24 minus 20 is 4. So this lets me know that this triple checks out. Okay. How do we feel about the substitution method so far? Not terrible? Cool. All right. So we're going to, so this one we did substitution with a little bit of elimination. The next one, it's going to be full-on substitution. So we have example 2, x minus 2y plus z equals negative 4, negative 4x plus y minus 2z equals 1, 2x plus 2y minus z equals 10. And so equation 1 is in standard form, equation 2 is in standard form, equation 3 is in standard form, and so therefore 1 is satisfied. Step 2 is to decide which equation am I going to use and which variable am I going to get by itself. I have a couple options.
1 and z.
I can do 1, I can do z, I can do 1, I also can do x, right? So how
Yeah, but
I
I would
solve
do z.
and how Devin solves it may be different. And since Devin said let's do z, we can do z, okay? So if we do z, so we're going to use equation 1, which is x minus 2y plus z equals -4. That means my goal is to get x by itself, z by itself. So I'm going to subtract x and add 2y. So subtracting x and adding 2y leads us to say z equals -4 minus x plus 2y. So in the end, step 5, once we know the values of x and y, then we can solve for z. Okay? So then step 3 is to substitute this into the other two equations for z. So on equation 2, we're substituting in. We have -4x plus y minus 2 times z, which is -4 minus x plus 2y equals 1. And we're going to distribute. We have -4x plus y plus 8 plus 2x minus 4y equals 1. Combine like terms, I have -4x and positive 2x, that makes -2x. I have 1y and -4y, that makes -3y, and 8 has to be subtracted, which leaves me with -7. So here's my first one. I'm going to do the same thing with equation 3. So we have 2x plus 2y minus -4 minus x plus 2y equals 10. I'm going to distribute the negative, because remember it's Casper, the friendly one right there. And that gives me 2x plus 2y plus 4 plus x minus 2y equals 10. Combine like terms, 2x and 1x is going to make 3x. 2y and -2y is going to go away. That makes 0. Does that make sense when I say go away? And then I'm going to subtract 4 to get it to the other side. So I'm left with 3x equals 6. Okay? And I can actually simplify this, get x by itself, because it's down to one variable. So x equals 2. And so I'm going to use substitution to solve for y. So I'm going to take the value and substitute it in for x for step 4. So step 4, I'm going to substitute x in, and I get -2 times 2 minus 3y equals -7. That gives me -4 minus 3y equals -7. I'm going to add 4. Gives me -3y equals -3. Divide by -3. So y equals 1. I meant to change colors on step 4. And then step 5 is to take my two variables that I solved for and plug them back into the equation in step 2. So we know z equals -4 times minus x, which is 2, plus 2 times y, which is 1. So it gives us -6 plus 2, which equals -4. So equals z. So our solution set is 2, 1, -4. If you look at the notes that are posted completely on your Canvas, I also worked the problem solving for X. It's a little extra step because we don't end up eliminating a variable like we did here. So you can see it worked a different way because there's more than one way to work it, since you do have two variables with a coefficient of 1. Okay. So again, on step 6, when you're checking yourself can be mental. It can be quick and simple. So I plug in X. 2 minus 2 times 1 is 2. Z is -4. 2 minus 2 is 0. 0 minus 4 is -4. Plugging this in gives me -8. 1 gives me +8. -8 plus 1 is -7. -7 plus 8 equals 1. 4, 2, and +4. 4 plus 2 is 6. 6 plus 4 is 10. And this triple checks out, so we know we did it correctly. Okay? So this was a full-on substitution example. We substituted our way to the very end. All right, the key thing with substitution is that you're looking to see if a variable has a coefficient of 1, or if you can make it have a coefficient of 1. All right, our last example is going to come from a word problem because, yes, systems and word problems are friends. So you manage a clothing store and budget $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy? So to begin this problem, you're going to first need to say what variable is what. So you're going to let X, Y, and Z be something. So we're going to let X equal our t-shirts, where you can let Y equal our polo shirts, and we can let Z equal our rugby shirts. So we're going to establish what our variables are. Then we're going to have to create our system. So based on what we read, what is the system that we're working with? So we have $6,000 and we restock 200 shirts. So we know that X plus Y plus Z equals 200, because that's how many shirts I have in total. And we also know that t-shirts cost $12, polo shirts cost $24, and rugby shirts cost $36. And I have a $6,000 budget. I also know that I want to buy twice as many rugby shirts as polo shirts. Rugby is Z, so I know rugby has to be twice as Y. Now I'm set up to begin going through my process of elimination. So step 1 is checked. Equation 1 is good. Equation 2 is good. Equation 3 is good to go. Okay? Because it's going to help me. So you could technically rewrite equation 3 and then rewrite it again, but there's no point. So we're going to say it's good to go. Step 1, done. Step 2 is you're going to decide on which equation and which variable that you're going to use. So the clear choice is equation 3, Z equals 2Y, right? Very clear, very obvious that that's what we're going to use. Variables by itself, it's already ready to go. All right, so we have Z equals 2Y. And then step 3, we're now going to substitute that into the other 2 equations. So we're going to substitute that into the other 2 equations. So in equation 1, we have X plus Y plus, instead of Z, 2Y equals 200. Combine like terms. So we have X plus 3Y equals 200. And that's our first linear system, the first linear equation. And then we're going to plug into equation 2. And that gives us 12X plus 24Y plus 36 times 2Y equals 6,000. Gives us 12X plus 36 times 2 is going to be 72y. So 24 plus 72 is 96y equals 6,000. Because these are all factors of 12, you actually can simplify if you don't want to work with the big numbers all the way through. So if you do not want to work with these with 6,096 all the way through, you can go ahead and divide everything by 12. So if you choose to do that, then instead of working with this, you're working with x plus 8y equals, is it 500? Right? Yeah. So you can either work it like this, or you can simplify it and work it with smaller numbers. Again, 100% up to you. You don't have to have the added step, but if you see that there's a greatest common factor between all three terms, you can go ahead and divide that common factor out and work with a smaller number. Any questions about what we just did? Okay, so at this point, we're on step 4 now. Step 4, you have to decide, do you want to solve your system by elimination or substitution? It doesn't matter, either one. So let's just do substitution.
Elimination, because the x is already ready to go.
Devin said we're going to do elimination.
Negative it. Change the symbols is all.
Yep. So I'm just going to change the signs of the one on the bottom. Negative, negative, negative. I'm going to multiply by -1. Eliminates my x's, leaves me with -5y equals -300. Divide by -5. So y equals 60. Okay, so I can take this value and substitute it in to solve for x into either one of these. So I'm going to go for the smaller one. So I have x plus 3 times 60 equals 200. So x equals 200 minus 180. So x equals 20. And I'm also going to take y for step 5. So our last and final step is go back to equation 2 and substitute in. So I'm going to take y and substitute it into equation 2. So that gives me 0 equals 2 times 60. 0, not 0, z. So z equals 120. Okay, so we have our numbers, so we can put it in terms of the problem. So that means I can buy 20 t-shirts and 60 polo shirts and 120 rugby shirts in order to make myself happy and get the most out of my money. Or not most, but whatever I'm trying to gain here. Okay? And that concludes the problem. How do we feel?
Good.
Good? Awesome. Because you have very similar one as your practice. Just changed a couple of numbers, but it's for you to practice going through, identifying, setting up, and then you have just a regular system, straightforward to evaluate. And that is it.